Hello everybody and welcome in this real first Skuldenka devlog. Past months I've been working on the next version of the project, which will change how we model our program in it in order to go from our proof of concept oriented tool to our real functional tool. Right now I've only done some modeling, so diagrams and again diagrams and more diagrams, some algorithmics and stuff like that. But before I'm going into details of the second version of the model of Skuldenka, which will be for a later video, in this video I will speak more about how is Skuldenka right now, the model, because it's much more simpler and much more close to what traditional programming is. Because of this, I want to take this opportunity to introduce the base concept of Skuldenka, which will not change in later versions, for you to better understand in next videos. Let's have a quick reminder of what are the goals of Skuldenka. The main idea is to create a programming tool which will be mostly game oriented, but also fitted for general programming tasks, mostly oriented on modularity. So the idea is really to create a tool for creating modular softwares that the user can change easily. The idea is not really to enable developers to change the program, even if it's like a natural consequence of the thing, but more to enable users to customize the program as much as possible and as easily as possible. For this, we will do three main things. The first point is to expose architecture of the program to the user so you can see how the program is made and how components of the program interact with each other. Second point is to allow user to swap and replace easily components from one program to another or from a library of components to the program itself. For this, we have to expose also more than architecture, we also have to expose what components are doing at which point. It's part of the architecture, but it can go a bit deeper than that. And finally, we want to have a tool for ensuring as much as possible that the new program created by customizing the old one is valid. For this, I mean, like, we don't use like components that are mutually exclusive, or we don't use components that are not fitted together. I prefer code-based tool. So first it will be code-based because it's much more simple to implement. But in the future, I want to try to have it, having it a GUI, like a graphical user interface. So the GUI will come in later iterations. From a developer point of view, development workflow of Skuldenka is a bit different, but not so much from a traditional programming tool. In mode of programming tool, and by this I mean a compiler tool set for a programming language, like for example GCC or for C++ and C, the flow is pretty straightforward. You write code which is at the same time architecture and instruction sequences of your program, then you simply compile it, and if you have several files, you compile it in several objects which will be linked together later, and you make an executable program and you run it. In Skuldenka, it's a bit different because we have three different entities that have to be made kind of separately. Not exactly separately, but which definitely not have the same meaning in the program. First, we have specification, then we have implementations, and finally, we have architectural description of a program. And when we have these three stuff, we all put them in Skuldenka, we all load them with Skuldenka, and we tell Skuldenka to run the program. Specification and architectures are known in Skuldenka. So Skuldenka knows what they are, and they are kind of normalized. You have one way to tell what they are in Skuldenka. I will comment that later. Emblems are opaque or can be opaque for user and Skuldenka, and they can be considered kind of libraries. They are described by specifications and allocated somewhere by architecture. How do we model that in the current version of Skuldenka. First, specifications are handled using traits. Traits are simply a collections of prototypes of method, so it describes what you can do with the object, and it doesn't say how you do it. So it's, for example, a method will be I can sit on a chair, and it will be just sitting, or I can put something on a chair, and it's I can put something, and yeah, the method, one parameter, etc., etc. And it states eventually restriction of what you can use for performing the operation. For example, I can only put something solid on a chair. I can put a liquid on it. Then we have implements. Implements are in the model called implements. They are a collection of both data and methods, which are related to one or more traits. So for example, my chair will have the trait of putting something on it, the trait of sitting on it, the trait of wooden object, and etc., etc. So I can put something on it, I can sit on it, I can burn it, or stuff like that. That's actually the components which will make a program later. We don't have to know how they work. We only know what they do when it comes to Skuldenka. However, we know what we can do to them using traits and what we can do with them as well. There's a bit of more of restriction, and I think it's what really makes Skuldenka different from other languages, from most of other languages or programming tool you can see outside, is that an emblem cannot use directly another emblem. For using another emblem, let's say for example, I'm making a game and I need physics simulation, I can just select I want bullet physics for this. I have to say I want physics library which has those characteristics, so I want maybe soft bodies, simulation and other stuff. And later in the program, it's a request, I want that, and later in the program, when we build the actual architecture of the program, we tell, okay, so my game needs physics, and for this we will need bullet physics, for example. Finally, we have an architecture of the program. The architecture is actually the program itself. It's called program, and it's also emblem assigned. The idea is that when we create a program, we just said right before that emblems are doing requests for getting other emblems. What we will do is just recursively select one emblem for each request of each emblem. And if the emblem we select as also request, we have to choose emblems for that. Finally, when we check the program, we only check that every requirement, every emblem, and every request are well matched together. If an emblem requests another emblem which can put things on it, if I give it, I don't know, maybe a wall, I can put something on a wall because like gravity, then it don't work. But if I give it a chair, which implements put on it, I can put something on the chair, it works. Awesome. Of course, if I chose to change this representation, is that there's kind of a limit. And the limit is on the way we express dependencies and compatibility between every implementations. It's really hard to make like multi-implementation or restriction on other implementation from an implementation through its specification. For example, if we want to make an adapter that is a part of the types we manipulate. So if you want to make adapters, it's really hard. If you want to make like really flexible adapters, which will be built in the programming tool, it will be really hard. Adapters are some kind of an add-on, like derived from the adapter pattern, which is like added to an emblem to manipulate them as if they were implementing more traits. It's not really something awesome for development, like final development, because there's a big drop of performance we can expect from this. But at the same time, they're really good for prototyping. If I'm a bit more determined user to have some feature, I can use adapters to check if I really want this feature and ask the developers of the program or other developers, hey, maybe it's cool to have this. The idea is really simple. If you have a set of traits, let's say you can sit on it, The adapter provides another set of traits. Let's, for example, if you can sit on it, then I can tell you how to put something on it and also how to stand on it. As an example, we have a 2D shooter games and we want to quickly try to adapt one of its gun to fit a 3D game. The gun is really simple, it's only two emblems. The gun itself, and it's requiring a bullet. We want to take all the gun, so both the gun and the bullet. Of course, they both implement a trait, which is 2D object, which allow to manipulate the object in a 2D space. So we have this implementation, 2D object, 2D gun implements 2D object. It needs 2D object as bullets. It's the name we will refer to the bullet creator in the gun. And it has one single method. And finally, we have one emblem assign, which is gun 2D, will be bullet, and will be bullet 2D. Those 3D games need to have 3D objects, not 2D objects. We need to write an adapter from 2D to 3D. The idea is really simple. We had one dimension on most of the transformations that can be done on the object. Either you discard them or either you make them if you can. So the adapter is really simple. It takes a 2D object, and if the 2D object, it takes an emblem, and if the emblem has a 2D object trait, then 3D object trait is also on the object. So now we have a new assign of some 3D character, which will use gun 2D as a gun using 2D to 3D adapter, and a bullet using bullet 2D. With the current skuldenka modeling, this program is valid. However, this program is of course invalid from a programmatical point of view. Bullet 2D is only a 2D object. Our program will probably crash when you try to instantiate and use a bullet 2D as a bullet 3D using getBullet. Of course, the solution would have been to simply adapt bullet 2D with our adapter as well. However, imagine wanting to transfer an emblem made of 10 or even 100 or more emblems. We don't really want to do this by hand. We want Skuldenka to tell us, oh wait, you are using something that's really messy and really strange. We should do this and this and this, and also this needs to be adapted and everything like this. We want to be a way for the developer and for us to, in our adapter, specify that bullet, like getBullet results, should now be 3D and not 2D. And that's really complicated to do with traits. That's why in the next video I will present you constraint-based model, which I first intended to kind of mix with traits. But since the trait concept can be also expressed through constraints, why not using only constraint? It will make the model a lot simpler. This is for the next video. Thank you for watching and see you later.